So the last video, I think maybe sounded like I was in a toilet. I don't think I got my mic settings perfected, but we'll figure that out as we go along. Anyways, it's now week 2 to 3. Technically, it's my second video, but we are grouping those last 2 weeks just because of holidays. So we've covered a fundamentals course, which I probably showed in the last video, and this is all from derivative. It's longer than it looks. I actually went through and calculated the total amount of time of all the videos, as you can see here. It adds up to about 7 hours worth of pure content. However, it's going to take you longer if you follow along. So add an extra 50%, maybe even double it. And that's around about how much time you should probably dedicate to that. And then there was the first creation, I guess. First replication of a new tutorial that wasn't like a beginner's course or beginner's tutorial or anything. It was just a purely normal tutorial to create something. And the output for that was also super sick, which I will show at the end. I will start by going through the fundamentals course and the file that I built alongside it. This is the first example I followed along with. It's essentially, it's like an example of instancing where we can have two 2D objects. We can lay them out, transform them, and use another layout to sort of instance it in a certain pattern. Not that complicated. Next, we have a custom bloom effect. I'm not sure why this was in the tutorial because there is a bloom operator within the software. I guess it's just maybe showing how to use the threshold, the blur, luma level, and that kind of stuff. Here we have our first example of feedback. And feedback is essentially a node that you need to create a loop with. In this example, we have a rectangle which is being transformed and has a HSV adjust, so the hue is being adjusted. It goes into a final composition, which then feeds back into the feedback, which then runs it again. Think of it as like a mirror effect where you can create a loop and then repeat an effect however many times as you go down. This is from the chop section, and it goes into different syntaxes for how we can select things. This is the first cool interactive example that you get shown in the course, and it's essentially building a container using a panel to pull out values from that container, and then a trail, and then mapping that trail. And so what are we mapping? Well, it's actually mapping the mouse movement. If I move my mouse here, you can see that it's drawing on a 3D plane, which is really, really cool. This is more for interactive sort of examples. Next, we went into collision, or had a collision example. This one is cool. Essentially what this is a render sequence. We are rendering two spheres. One, we've just put a line material on. Another, we've just put a constant material to differentiate the two. The main idea of this tutorial was showing this object operator. And what we can do with it is have a target and a reference object, and then it will give us the distance between those two objects. And then we can build a logic component. We can define the bounds here, and this logic will show off when outside those bounds. What that means is we can set a distance and essentially make that a collision distance, which if I show here, it is now outputting 1 or 0 for in or out, essentially creating a collision parameter. I think when you build a more complex project, this can be really cool. Starting with the subsection, we have an example of basically changing a line's shape according to a pattern. So the line goes into a chop 2, which feeds its pattern according to this one down here. This next section covers what an attribute create node does. We can see what a facet node does. We can see how if we change the noise to point normals or point diffuse color, the kind of output variations we can get. And then we also had a little example of applying noise to a grid and seeing how we can make almost like a little landscape of sorts, just using noise and a grid. Very, very simple layout, giving us a rather complex and interesting result with very little effort. Here we have a simple animation, spinning cube, moving sphere, simple animations and render setups. So this one here was an introduction to using a camera path and also the look at, which we had covered before in a different tutorial. This is the first time that I've been able to, or that we've been able to see how we can build a path for our camera. The next part was rendering shadows, which I hadn't seen before. The shadows require specific materials. In this case, the Phong materials were used, and a very simple geometry sequence was created with a cube and a grid. And then we get this very cool little shadow creation. Okay, yeah, this section was working with different types of materials. Here we have imported a custom texture, or custom, I guess it's just an image file. Then through this constant, which reads from that null of the image file structure here, we can then put it onto whatever shape we want. Then we have another example of using a Phong texture. And finally, we have more complicated options like drawing vectors for a line texture. Here we have a more complex example of texture, and this one uses physically based rendering, so it's a PBR texture. This is like an introduction towards more complex sort of textures, more custom and complex textures that you can make. Then we go into containers, which is a way of displaying information. I can have, for example, a container with parameters where I can influence another node next to that. We get into more structuring the containers, how they work, container hierarchy. There's some examples of references using Python to link the radius of this to the size of that one there. As you can see, when I change the size of the square or the rectangle, the circle also changes. This is one-way reference, and this is a two-way reference via the bind. Just simple Python expressions referencing and binding parameters across nodes. This is a more interesting one. Once again, it's for interactive use cases, but we've actually managed to build a painting interface. What we've done is we've basically pulled out the values of the mouse from within this container and when it's been left and right clicked. And then this circle's radius is determined by whether or not a left click has been registered. And then the feedback and the over are basically ways of caching information from what I understand. And yeah, it allows you to draw. This is an example of using custom settings on a base composition. So inside here we have a network, and in this network we have a number of settings like HSV adjust or a mirror. Okay, now it's working. So now we have a slider for the HSV, some more UI creation using containers, organizing things, having a little layout and customizable controls next to that. Even more complex layouts we have here with buttons and sliders. And moving on to a little bit of Python, we have a way of binding colors between two operators using Python here. And then we have an example of a chop execute dat. This line here, when we get an off to on signal, we print running. When we get an on to off, we print not running. And if I run this LFO, you can see as it changes between the two states, it'll print out running or not running in this text. Finally, some extras here. So there's a lot of tools in the palette section, and you have like templates. So you can create some cool things based on those templates. There's this particles one, which I thought looked pretty cool until I opened it. And I realized that we have a long way to go. I honestly have no idea what I'm looking at here. So this is the goal, I guess. So that just about wraps up everything that's covered within that fundamentals course. There's a lot, and I would highly recommend doing it if you've never used TouchDesigner before. It's quite dense, so there's plenty to learn from there. Yeah, it should take you about between 7 to 15 hours, depending on whether or not you follow along with the examples, which you should be doing. So this is the first tutorial. This is the channel that I got it from, just here. This tutorial uses pops, which I had never used before, but you get this really, really cool visualization you can see here. Very, very proud of this one. The camera movement was not shown in the tutorial. I added that myself based on what I'd learned. So we are getting somewhere. Let's start at the beginning. So I imported a movie file. This is footage I had filmed myself. We have a level here in case we wanted to change anything, which I hadn't touched. Then we convert it to a pop. In doing so, you can adjust the setting here. So this one's pulling the color. This one's pulling a height. And if I zoom in here, you can see that it's actually creating a sort of height map based on the pixels of the movie input. Then we combine the two, and now we have like a colored semi 3D visualization. This next part I didn't fully understand, but we're essentially creating randomization values. This one, we're creating a scale parameter of sorts, and then this one we're creating a rotation parameter, and we are copying according to rotation and scale. I don't fully understand how this section works, and this is something that over using more pops and creating more complex noise and distorted visualizations like this, I would understand, but until then, so we have a noise here. If I reduce the noise, we can see how we are taking those previous nodes and sort of twisting it in 3D space. We're then taking a box. This is essentially like making a really small box, so it's almost like a pixel, and then using a copy operator, we're able to copy a box to each point in this, what is essentially a point cloud. Then we feed it through a render sequence, and we also add a feedback section, the little feedback loop. And then finally, there is a little bit of blurring. So you can see here on the edges, if I pause here, the blurring is also working on the sides. We've just created a ramp and put that through a Luma blur to get that edge blur effect. Let me just fix rotation here. What should happen is we have a rotating camera. The way I built these two is just I use the timeline, I use the math to adjust the range from 0 to 600 because that's my timeline, to 0 to 1 because that is what the camera is reading in terms of essentially like a normalized position value for this circle path. And that is the first finished product. Okay, so what is next? What does week 4 look like? I wanted to continue with the TouchDesigner curriculum, and after the fundamentals, there is actually an intermediate course. We will figure out if that's doable in a week, or worst case scenario, we do it over 2 weeks. And then another tutorial. I thought I'd actually add a POPs tutorial as well, because I think there's a lot of value and a lot of cool things that I want to learn in the POPs operators. All right, time to get to work. Stay accountable, stay focused, and I'll see you next week.